So this will be the second part of the review sheet. So we're going to fully simplify these radical expressions. So the first thing I want to do with 48, start breaking it down since that's not one that we know. So you have 12 times 4, and here we have 3 times 4. We could break the 4s down further, but they got a buddy, so we could go ahead and pull that. So there's a 4, and then 3 is left. 4 radical 3. 75, end up with 25 times 3, which is 5 and 5. So you got a 5 that you can pull out, and then 3 is left behind. Here, 200, you got 100 times 2, and 100 is 10 times 10. So we can pull a 10 out. There's already a 3 there, so that 10 and the 3 join up, and that becomes a 30. There are 4 r's underneath. They can all, quote-unquote, make a break for it. 2 will get out, and then you get that 2 that gets left behind underneath the radical. Here we need groups of 3, so 216. 4 will go into it. So you got 2 and 2, and then 54. We can divide that by 2. That's 27. So you have 3 times 9, and 3 times 3. So again, you see that index on the outside of 3, meaning we need groups of 3 here. So we got a group of 3 2s right there. We got a group of 3 3s, which means they both get out. A 2 and a 3 both get out, which means we end up with 6. There's enough 3s for a group, or enough x's, excuse me, there are 3 of those to make a break. 1 will get out, and then there is a y left behind. Don't forget that little radical right there at the end. All right, so cube root of 27, well, again, 27 was 9 times 3. Break 9 down to 3 and 3. Well, we got a group of 3 3s. They can make a break for it. And then there are 2 groups of x's that can make a break for it. And actually, nobody's left behind. Here again, so here we go with 200. So with the 200, we have 100 times 2. And 100 is 10 times 10. Again, I could keep breaking it down further, but I'm looking for pairs. I've got a pair of 10s that can make a break for it. So those 10s go. They join up with a 5 that's already there. So that turns into 50. One x can go, and 2 y's. And what gets left behind, you have that 2 that's left, and then there's 1 y that's left as well. So when it comes time to add and subtract these radicals, remember we want to get like radicals before we add them up. We can actually do that initially here. You got square root 27 square root 27, so you have 5 root 27 minus root 24. But these are numbers that we can break down a little bit. So let's break this down. 27 is 9 times 3. You have 3 times 3. And then here we've got 6 times 4, so 3 times 2, 2 times 2. So a set of 2's can go. If we have an opportunity to break these down, we need to further. So those 3's right there will join the 5 that's already out there for 15 root 3. Those 2's, and then a 3 and a 2 are left, so it's 2 radical 6. Right. Again, if I have some like radicals right away, I might as well go ahead and put those together. So you have 2 root 8 minus 3. So that turns into minus 1 radical 8. And now let's break down what we have. All right, so 18 is 9 times 2. I end up with 3 and 3. So those 3 can break out and join the 3 that's already there, and that turns into 9 root 2. And then here we got 4 times 2, 2 times 2. So there's a set of 2's that can jump out. So you end up with 2. You have 2 left behind, right? You still have that minus you got to bring down. So 9 minus 2. Now all of a sudden we have the like radicals again. So our final answer is 7 root 2. 35. 5 radical 5 minus 2 radical 5. Well, those are like radicals, so I can put them together. That's 3 radical 5. And then plus radical 2. No, I said radical 5, but for some reason I wrote radical 3. So there's that one. Here, none of them are like radicals, so let's try to break some of these down. You end up with 4 times 3, 2 times 2, so we can break that 2 out. So that's minus right? We join that with the negative 3 that's already out there. 8, 4 times 2, and 2 times 2. So those 2's make a break. Joining the negative 2 that's out there, it turns out into minus 4 root 2. And then 18 is 9 times 2. So that 3 can make a break. There's nothing out front for it to join. And there is a set of like radicals in this particular problem. You can see the minus 4 root 2 and the minus 3 root 2. We have like radicals. So nothing for the minus 6 root 3 to join. But minus 4 minus 3 is minus 7 square root of 3. Or 2. Yeah, I'm saying one thing and writing another this morning. So, all right. So we turn the page. Now we multiply the radicals. Remember, when you're multiplying, in goes with n, out, right? So if they're in jail, they can only multiply what's in jail. If they're out of jail, they can only multiply with what is out of jail. And then make sure we simplify at the end. So right here, 5 is out, nothing to multiply it with, but the 3 and 3 are both in, so we can do 3 times 3 is 9. We're not quite done because we know what the square root of 9 is. Well, that's 3, so we have 5 times 3. And we can do that. 5 times 3 is 15, right? 10 is out, 3 is out, so that's 30. 9 is in, 4 is in, so we have 36 that's in. Again, we know what the square root of 36 is. That's 6, so 30 times 6 is 180. All right, 3 is out, 2 is out, so we have a 6. The 4x is in, the 5 is in, so we have root 20x. Let's see if we can break 20 down. 20 is 4 times 5. There's 2 times 2. Sure enough, we can get a 2 out. That 2 will join the 6. It becomes 12. 5 is left behind, and there's an x as well. Everything is in. So we can do 5 times 15, 75. There's 2 x's plus another x on the other side. There's 3 total x's. And there's 4 total y's, and everything is quote-unquote in jail here. All right, so let's break down 75. We end up with 25 times 3. It's 5 times 5, so 5 is going to break out. 5 is out. One set of x's can go in 2 sets of y's. And then what's left behind? We have a 3 that gets left behind along with one of the x's. All right. Now we have the distribution process. 6 is quote-unquote in jail, so is 3, so they can multiply together to be square root of 18. 6 is in jail, so is 7, so 6 times 7 is 42. Again, don't stop here. See if you can break these down. This is 9 times 2, 3 times 3. So sure enough, we can break a 3 out. This was 6 times 7. That's 3 times 2. Nothing can break out of the second one. So my final answer here, 18 can turn into 3 root 2. There's nothing I can do with 42. So I'll leave it as 42. So there's your final answer. And since those aren't like radicals, I cannot put them together. Here, 3 is in, quote-unquote, in jail. 20 is not. So we have 20 root 3. And then 3 is in jail. The other 3 is. So this can turn into plus square root of 9. Not quite done because I know what the square root of 9 is. If you know a square root or if you can simplify, you need to do that. So there's that. Now it becomes time to FOIL these things. So square root of 2, square root of 2, both are in jail. That turns into square root of 4. 2's in, 6 is out, so they cannot mingle. 5 is out, 2 is in. They don't mingle. But 5 and 6 are both out, so negative 5 times positive 6 is minus 30. Now it turns into combine like radicals. So that turns into 6 minus 5 is 1 root 2 with a minus 30. And the square root of 4, we know what that is. That's 2. And here, we can take one more step with this one. And 2 minus 30 is minus 28 plus 1 root 2. Let's FOIL one more time. So 3 and 8 will be square root of 24. Square root of 3 and positive 1, they don't mix. 6 and the 8, they don't mix. So 6, 8, and then 6 and 1, they go without mixing. Now, a few of these we can break down and simplify. So let's do that now. So 24 breaks down to 4 times 6. 2 times 2, 2 times 3. 3 doesn't break down, but 8 does. 4 and 2, 2 and 2. So let's see if we can combine anything once we simplify these. So that 2 gets out, and a 2 and a 3 are left, so root 6. You have a root 3. This 2 gets out. Joining the 6 that's already out here, that makes that 12 root 2 plus 6. And none of these are like radicals. We have a radical 6, a radical 3, a radical 2. Nothing can be combined right there, so it's just kind of a big, long answer. And one more problem. Remember, when you have problems like this, you have to consider this to be 10 minus square root of 3 times 10 minus square root of 3 before we start doing our FOILing. So 10 times 10 is 100. Then we have 10 times negative square root of 3, so 10 minus root 3. Here we go, root 3 times 10. 3 is in, 10 is out, which means they cannot mix. So minus 10 square root of 3. And then finally, the square root of 3 and the square root of 3, they're both quote-unquote in jail. Negative times a negative is positive, so plus square root of 9. So we end up with 100. These are like radicals. That turns into minus 20 root 3. And then square root of 9 turns into plus 3. So at the end of the day, we have 103 minus 20 root 3. Can't simplify it any further than that. Remember, with imaginary numbers, anytime there's a radical or a negative underneath a radical, you pull out an I. So we know the square root of 144 is 12, and since there's that negative, it's 12i. Negative 20 is not one that we have, but that's 4 times 5, excuse me, and then 2 times 2, so I can pull out a 2. I can pull out an x. Remember, there's an I because of that negative underneath, so that 5 is left, and a y is left. Here there's a negative underneath. 120 is 12 times 10. 6 times 2, 2 times 5, 3 times 2. So let's think for a minute. We can pull that 2 out. We can pull an I out. There's 7 x's underneath there, which means 3 can come out. Also, 3 y's can come out. And what's left, we have a 3, a 2, and a 5. So 3 times 2 is 6, times 5 is 30, and there was 1 x that was left behind. Here's when you combine, essentially combining like terms. So if it has an I, put it with anything else that has an I. So 3i minus 7i is minus 4i. And then 2 plus 2 is 4. Here, just remember to distribute that negative because it's outside the parentheses. So we have 23i minus 6 minus 2i minus 2. So negative 6 minus 2 is minus 8. 23i minus 2i be plus 21i. And there you go.